For our next talk, we're going to hear from Oscar Delgado, who has been working as a process engineer for over a decade, working across system engineering, design, analysis, and troubleshooting of equipment across a wide variety of different critical infrastructures. And in today's talk, he's going to discuss cybersecurity, but really more from a process environment and the operations view and engineering perspective. So with the years of experience across the number of different environments that he has worked in, and that experience that's going to be brought to us here in this this presentation, it is definitely kind of interesting to hear the self as an ICS student. But many of us, we're uncomfortable if anybody, when we're introing somebody and we say, well, they're a subject matter expert. A lot of people kind of opt out of that that designation, and they say we're constantly learning. Every new facility we go to is tell us how you do what you do here, and it's a continuous learning environment. And I think even if you've been in this field for 30, 40 years, you could still classify yourself as an ICS cybersecurity student.
Okay, so thank you very much for this opportunity. As I said, my name is Oscar Delgado, and today I would like to talk about process analysis, process diagrams, unit operations, and why I think this is important for cybersecurity professionals. So who am I? I'm a chemical engineer. I have been working in the past 13 years in different industries as process engineer, and project manager, mostly in oil and gas, mining, and nowadays water and wastewater treatment plants. Before we start this talk, I would like to ask you a question. Imagine that this is the first day in your job, in a new job, or you have a new assignment, right? And somebody asks you to, give you some piece of information and say, please check that this plant or this new process is well protected or well defended. So the question is, what is the first thing that you will do as a cybersecurity professional? And if you want to type the answer, just take 1 minute to think about it. And I start with this question because I have been asking the same questions to several people in the past months. And for me, it was kind of surprising when I heard that understanding the process was not one of the top priorities, right? So there is a difference between IT and ICS, and the ICS has this physical world attached to it, right? When we change set point in a screen, or when we open a valve in an HMI, you know that there is a valve somewhere in the plant, right? That is opening or closing, and you know that that has a physical effect. You know that we are increasing temperature, we are changing flow, we are changing pressure. Yet sometimes I feel like when we are talking about ICS, process is in one corner, right? We are here, we are looking at ICS controls and everything, but the process is right there. So my proposal and the motive for give this talk is I want you to propose that we look at the process before we actually start thinking how to protect it. I want to put another example, and it's like 3 weeks ago, we have this incident in Florida with the water treatment plant. And I was following a lot, all the news, all the articles, or the blog posts. And yet, it seems to me that just a couple of all that information was talking about the actual process. And as a process engineer, that have implication, right? Because you can add caustic in several parts of the process, and you will have different consequences depending on where you are injecting the caustic. And again, for me, okay, we should start any discussion by talking a little bit about the process, what is important, and then we can start talking about controls and all the protections, right? I think we need to understand what you want to protect. Okay, so what is this important? I just told you what is important to me as process engineer, but I think that we have another two very important reasons. First one, improve effective communication. And I'm thinking here about two groups, the operations teams and the management team. I don't know if in the past you have experienced that you have this amazing idea, you have this project, you are in a meeting with management or operations, And as soon as you start talking about your idea, you feel the pushback from the operations team, from the engineering team, or from the management team. And they say, no, 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 you're not going to do that to our system. And it's not something personal, and it's not something about the idea of the project. Most of the time, it's about trust. They don't trust that you understand the consequences of doing something to the process. They don't trust that you understand that a little change in one part can have cascade effect in the rest of the plant. So when you can demonstrate that, yes, you have an understanding of the process, the communication between the teams is improved. The second reason I give for this is helps you make better decisions. And I'm thinking here about risk evaluation, right? When you are thinking, okay, what will happen if you have a better understanding of what will be the answer of that. Also consequences, right? Priorities. So that's why I think the IC security professional must know a little bit about the process. So how can you do that? So there are several paths for that, right? I want to show you here is what I typically do as a process engineer. It has worked for me in the past. I have to study a new process like monthly. So I think it's simple, and I think it can help you to do the same. So this is a process flow diagram. So don't pay attention to the details at this point. I just want to show some of the typical tools that we use. If I give you this piece of information, how long do you think it will take you to understand what is going on here? Here is another example. This one is very, very simple, right? Same question. How long do you think it will take you to understand this? My goal is I want you to show you today a technique that you can use to understand process like this and even more complex, and that can help you to understand and explain this to somebody in just a few minutes, okay? You shouldn't be intimidated for any of this. So I have a methodology, and that methodology is something based on unit operations. The big idea here is we don't want to look at the details, right? There are so many details that we need in a complex plan, and that could be like a rabbit hole. What we want to do is to look at the big picture, like the big puzzle, and see what is common. So unit operations, think of that just as Lego blocks, right? Those are building blocks. And the idea is that we want to use those blocks to represent any operation in a normal process. Those blocks are encompassing equipment and operations that have similar physical principles or similar techniques, right? And the idea is simply we just take one of those blocks and put it in the process. I want to give you an example of what I mean by these building blocks. So sometimes, for example, you can start talking about homes, right? And you can start talking about the heating system for your home or the air cooling system for your home. And this home can be the building block, but it actually could be a house, could be an apartment, could be a trailer, a ranch. So, but when you use the word home and you think as home, you are encompassing several different examples of this home, right? And this is what we want to use here. We want to use something that is very common, and we can use it to represent many other things in a real process. Another example, I don't know if you ever watch a program named CHOP, and I really like the mindset of some of the participants. So basically, for those who haven't watched the program yet, there are 4 participants, and they receive some mysterious ingredients, right? Or some weird ingredients, and they have to produce a successful dish. And if you listen to the interviews, sometimes they don't know about this specific ingredient of something, but they know about the group, right? So they don't know, okay, I don't know what is this, but I know it's a vegetable. So, and I know how to deal with vegetables. I know this is a red meat or a white meat. I have something that I say that they don't teach you how to make fettuccine or how to make spaghetti, but they teach you how to make pasta. Because the basic technique is that, right? And then you can apply to different situations. this is exactly the mindset that we want to use here when approaching new process studies. So those are the unit operations that we are going to use for building any process, right? So there are three things that I would like to say about those. So first one, we can use it several times, right? There is no limit, and we can put 3, 4, 5 blocks of heat transfers in a process if we need it. Second, we can use it for different purposes. So for example, again, heat transfer, I can use it for cooling, I can use it for heating, for vaporization, it doesn't matter. And the third thing is, I like to say that we can use different colors, meaning that we can put a little bit of information in each block and give us like additional information, additional details about what is going on with the process. And I will give you examples of this in the next slides. Before giving the examples, I need to talk about chemical reactions, because technically the chemical reactions are not unit operations. So they are different, they are very interesting, but they are not unit operations. For our analysis, we assume that it's just another building block, right? So now we have 5 blocks to use, and we are going to simulate any process using those blocks. So the first block is going to represent anything that involves movement of a fluid. It could be liquid, gas, or could be two-phase, right? You normally see these fluid mechanics as a pressure difference. When you have a zone of high pressure and a zone of low pressure, you see this movement. So we want to use this block to represent anything like that. This fluid mechanics is very, very common in any plant, even if sometimes it's what we call utilities. So sometimes you will see like the principal process has fluids, but sometimes it's just the water that go into the office. So you will see this block very often. This PFD I showed you in the past, this is the styrene production, right? So what I'm going to do is I'm going to use this, and I'm going to start plugging in here all the building blocks. And the idea is at the end of all these 4 or 5 blocks, we will see a process with a different eye. So our first block, I don't know if you notice the difference. Okay, let me try it again. So this is the original one. Now, well, we see here in the middle the brick green square, but other than that, what I did is I used my block, my fluid mechanic blocks, to hide the complexity, right? So this block is interesting because instead of showing here, what we want is to hide the things that are below that. So just one exception is if the equipment is very, very important. I'm thinking, for example, the gas compressor in an ethylene plant, or sometimes the pumps in water injection pads. Those pumps are really, really high pressure, high capacity, and very important, very custom pumps. You want to use the blocks. Otherwise, this block kind of hide everything that is below that. The second block will represent anything that is related with heat exchangers, right? So we see this heat transfer as a change in temperature or as a change in phase. So anything that involves change temperature, change in phase will be represented by these blocks. We normally say that those are heat exchangers, but if you go to the plant, you will hear different names. You will see that some operators say the reboiler or the top condenser, the side condenser, the side reboiler. And this is basically just based on the location of the plant, on the location of the process, but everything is just a heat exchanger. And the key term here is temperature difference. That's what you want to look when you're using this block. Again, so we were here last time, and now if we change, you see on the left that I put some blocks, and I was mentioned about different purposes. So you see that everything here that is red or blue are part of the heat transfer blocks, but they have here, I'm using on the top for vaporize my feed, and here right in the middle, I'm using for condensate the product. So both are part of the same group, but I am using different purposes. Same with the colors. And here I'm usually actual colors, but in general, that means that I'm putting these two sentences, two words here just to help me understand what is going on with the process. You will notice something here that on the bottom right, that I didn't replace these heat exchangers. And it's just because they are part of a group. When you have these towers, normally you have all the time, so 99% of the time you have reboiler and condenser. So instead of using individual blocks, I'm going to replace the whole thing when it's time, okay? Next one is mass transfer. And we will use this block to represent anything that involves moving components within one phase or from one phase to another. So you will see this in most of the plants. When you see a tower, it's normally related with mass transfer. Driving force concentration. So this is how you see this is not a kind of the physical principle for that. I think that a heat exchanger, understanding the heat exchanger is pretty easy. And sometimes it's difficult to understand mass transfer, but I want to give you examples because probably you don't use the term mass transfer, but I'm sure that you are familiar with examples like this. So first one says fragrance moving from one room to another. When you lit a candle or when you are cooking something, you can smell like the aroma around the kitchen or around the place where you have the candle. But if you move to another room in your home, you will realize that sometimes you notice the same aroma. And that's because the aroma is transferring from one place to another, from one region to another. And this is mass transfer. This is what we call diffusion. Same happen with the drops of dye of water. Or for example, if you have sugar and you put the sugar in your coffee, if you don't stir, but you wait, after some time, you will see that there is a uniform color, a uniform taste, and that's again diffusion. And the last one, I think is very interesting. When you are reducing a sauce, what you are actually is you are taking the water from the liquid phase and put it in the gas phase or in the air. And this is pretty much what is happening in a distillation tower. So I think now you can understand that distillation is just kind of reducing a sauce that you repeat the operation several times and just put it inside a vessel. So back to our sample. We were here last time, right? And now we're replacing. So what we see now is that these two towers here are basically to remove, right? And we are start seeing some characteristics of this process. We are seeing subproducts, we are seeing recycle. And now I think we are starting to understand better what is going on here. The fourth block is, we will use this block to represent anything that involves solids. So think crusher, grinders, screening. This is very, very common in mining industry. And here in Canada, we have in Alberta, what is the oil sands. So for those that are working on that field, you will notice a lot of operations involving solids. Unfortunately, we don't have any example in the styrene process, so we will just move. The last block, and is this related with the reactors? And hopefully you remember that I say it's not a union operation, but it's not important. We are just assumed that it's another block. And we were here last time, and now we have here the final blocks. So I want to take 1 minute to explain this process. Very, very simple, right? So we know that we have the ethyl benzene and we are going to vaporize the feed, right? Before enter the reactors. We add the steam, right? This will give additional energy. We produce the styrene in these two reactors, and then we just start the purification. We start by cooling and condensation. We have this three-phase separation, so we remove hydrogen and water. And then we pass to the yellow section to the right, where we are removing the light components, benzene and toluene, and then remove the ethyl benzene that hasn't reacted yet. And we have the styrene at the bottom. So that's the whole process. So By now, I hope that I answered two questions. So the first question was why is this important to understand the process? And the second was how you can understand one process. And I just gave you an example of things that you can do to understand the process. So what I want to do now is to show you, okay, you have this diagram. What can you do with that? What is the type of information that you can extract for that? And as I said, this is how we started, right? We start with this PFD and we ended with this. So I just tidied up a little bit the diagram, but it's exactly the same diagram that we saw in the past. But we can start taking information and making conclusions about this. So the first thing I would like to highlight is here in the middle, you see the ester in production, the two blocks, and I know that this is my production zone. And then I know that everything to the right of these blocks is related with product and everything to the left is related with the raw materials, right? What is this important? Sometimes you have process that the product is very, very expensive, right? So you know that any leak in the purification zone will be a cost for the plant. So when you are doing your risk evaluation, you are doing a consequence analysis, you will consider that. Same happen if, for example, your product is very, very nasty. So it's very dangerous for the environment or for the plant. You want to know from when you start seeing that product in your equipment, right? We can start using this same diagram also to see the interdependency and the order of the operations. So I know just by looking at these diagrams, I know that I need to vaporize the feed before I can enter the reactor, right? And I know that I need to cool and condensate my products before I can enter to all the separation phase, right? So I know what is the order of the operations, how I can affect a subsequent operation if I affect, for example, attack one of these blocks. I can also see the subproducts and the byproducts and the materials. So for example, I see in the three-phase separation, I see that I'm taking hydrogen and water, right? Just by looking at this diagram, I start thinking that probably I have different requirements when I'm talking about the hydrogen and the water system, right? Probably for hydrogen, I need to think about explosion-proof instruments. I need to think about area classification. I know it will be more of a risk. Maybe for the water, I can do more kind of standard instruments. So things that you can do from here. And the last thing I want to show is I talk a little bit about priorities. And if you see here, we have 1, 2, 3, 4, 5 blocks that are somehow related with heating, right? We see here for the vaporization, the product heating, and then the two associated with the distillation towers. If I were an attacker, I will say that if I attack the steam system for this plant, I probably will cause a lot of problems because you see that this steam is cascading through the plant, right? So any problem that I can create on this steam will not just affect one equipment, right? It will affect pretty much the whole plant. I can probably disrupt the entire production just by attacking that one. So when I'm thinking about priorities, I will say for this specific plant, the steam should be a priority, should be reliable, should be very robust, and something that I want to consider in all my scenarios. So I just show you how to do those analyses, but the good news is that most of the times you don't need to do it. You only need to ask for it. So what I was doing is I used this concept of unit operations to show something that is very common for process engineers, but not very common for the other disciplines, and is the block flow diagram. So what we do with this block flow diagram is do the same. We don't want the details and all the specifications of the units. What we want to see is the whole picture. We want to see, okay, what is going on at very high level. So there is, here I put an example that there could be thousands of piping and instrumentation diagrams. hundreds of process flow diagrams, but they are just a few things, block and flow diagrams. And this is something that I have experienced in my day-to-day job. And what I want to say is normally this is not included with the engineering deliverables, but it's there. And if you ask, and if you are just process engineers, there is a good chance that you will have it there. And believe me that you will see all the other documents with different eyes if you start by looking at this block flow diagram and look at the big picture. To conclude this talk, I want to give you a few key takeaways. If you want to slide capture, I think this is what you want to capture. So the first one is the ICS controls are very different from industry to industry. So my invitation to you is that you look at the process first, you understand the process, you understand what you need to protect. And this could be simply just going and talking with the operators, with the technicians, with the engineers. Most of the time, they are very welcoming. They are open to discuss the process with you, to teach you about the process. And my invitation is that you take the opportunities that you have to do it. The second one is that every single process, no matter how complex it is, you can disassemble in fundamental units. What my mental picture is always like Lego blocks, right? And they can be reused. And there is something that is beautiful about that. And is that once you understand these building blocks, you can use it in different scenarios, right? So there is nothing particular for the heat exchanger building block. So I can use it in a water treatment plant, I can use it in a refinery, I can use it in a salt plant. And my mental picture is the same. It's saying that it's something that is related with this temperature difference, right? And I can use it like that. And the last takeaway is that most of the time the block flow diagrams are done. I mentioned that it's interesting that you can use the process to improve communication. And for me, the block flow diagrams are excellent for high communication, for high level discussion with OT and management. And that's all that I have to say for today. Thank you very much for your time.
Thank you very much, sir. As you go look to the hallway discussion for your talk and the general, you're going to find just overwhelming amounts of praise in regards to just this is absolutely what we need kind of in every ICS focused conference, with a engineering discussion around how the process works and then what we need to do to safe that process and talk about cybersecurity, kind of all in that same discussion and space. I think I was heading down a path with a question and I saw one pop up as well that is very similar. So I'll modify mine to fit a little bit into that one, but really that conversation around bringing cybersecurity experts and people from the IT and OT who are working together to jointly try to defend these environments and getting them up to speed on how the process works and how it functions is absolutely essential. And then you should kind of envision this, hey, we built a bridge one way from the kind of engineers and process and instrumentation and control over to the cybersecurity professionals. And we're going to need to have an equal conversation to build a bridge the other direction in regards to the cyber digital assets and what risks they bring to impact or affect the process if they're misused or misoperated. And I guess it's just a question to you. With the great work you've done here, do you have ideas or thoughts around doing it the other way? Is that something you've already done or experienced? Any other guidance? And maybe it's a talk for you for next year. But I'm just curious to hear your thoughts on that.
Well, I think it's very important to have these discussions, and I think what is key for an ICS to actually defend the plants is to appreciate the difference in backgrounds that we have, right? So my background is process engineer, and I think when we are having these discussions, I really appreciate that we have different opinions. So I want to put an example. So again, the water treatment plant incident. I was talking with fellow engineers and fellow operation and technicians for these incidents. And I was talking at the same time with people from ICS, and we have different concerns about the same incident, and we were reading exactly the same articles, and we have different concerns, different questions. And for me, it was amazing to see this kind of, okay, how we have like different, our backgrounds somehow dictate what we are think, what are our concerns. So I think it's very important to have these conversations. That's why I was very grateful about this opportunity to show like, this is my experience, this is how I see the things. And what I think is probably we will need just to teach also process engineers and instrument engineers and mechanical engineers a little bit about cybersecurity. I think Joe was saying that there is no formal training for us. So normally we are told to, okay, we need to make this process work, right? And for me, the idea is, okay, I need to produce styrene or make fuel or drinking water, and that's my priority. But I'm not thinking, oh, yes, but you actually need to make it work, but also need to be reliable, need to be robust, need to be protected against these new cyber threats. And nobody is teaching us that part. So I think if it's just not the conversation, but also giving some guidance about what is important for you guys. And sometimes I feel like there are things that we can do differently, and we just don't do it because nobody's asking for that, right? If we don't know, we won't do it.
Oscar, I love your perspectives. It's an amazing talk. I think really every one of us probably is wishing we had our own Oscar working in one of our facilities where we could sit down kind of over lunch every Monday and walk through different processes and talk about how they're designed, how they're engineered, how they're intended to operate, what we're doing with kind of cyber digital assets, how they could be misoperated, and what we could do to mitigate the effect if there was an attack. And just everybody would continue to learn and grow from each other. All of us can hopefully count on seeing you at a number of ICS related summits and conferences, and we can pretend like we get to work with you through your presentations. But absolutely appreciate your thoughts on this in the presentation. It was fantastic.
Thank you very much. Thank you very much for this opportunity.